So today's webinar, what are we talking about today? Well, we're going to be investigating barriers to fish migration. And our speaker today is Brian Coghlan. Brian is a research officer for Inland Fisheries Ireland, and he works on the National Barriers Programme. Brian has worked in Inland Fisheries Ireland for the last 13 years on many projects involving river enhancement, fish population dynamics, water quality, hydromorphology, and climate change, to name but a few. And in his spare time, as you can see from his profile picture there, he is an avid pike and trout angler. So I would invite Brian now to share his audio and his video, and I will then hand over to Brian.
Hello, everybody. Welcome to my presentation. I just want to make sure it's, am I working?
Yeah,
Sarah?
perfect.
Yep.
Thank you, Brian.
We're up and running. My name is Brian Coghlan. As Sarah said, I am a research officer for Inland Fisheries Ireland. I've been there for 13 years, and for the last 4 years, I have been working on the National Barriers Programme with my line manager, Dr. Ciara O'Leary, and my assistant, Rossa O'Brien. And, well, it says it on the tin, the National Barriers Programme. That's what we've been looking at. We've been looking at barriers to fish migration in the Irish River catchments. So you can see here we are actually sponsored by the Department of Housing, Local Government and Heritage, who are supplying the funding for the programme. And it's been a pretty intense 4 years. This is the final year of the programme, and I think we've managed to achieve quite a lot. So for this presentation, how I want to run through it, I want to outline the effect of barriers on fish and the habitat, more importantly, the habitat, because without habitat, there can be no fish. What species I'm going to talk about, the species that are mostly affected, and it affects all species really. Why we're thinking about removing these structures, the barrier types that we do look at and do we survey, where we are in terms of barrier assessment in Ireland, and how we're moving on with that. Things we can do to make things better, the mitigation strategies that we can employ to make passage better for these fish species, and an example of a successful removal from Denmark there, that little fella there. So I think the overarching feeling from this presentation is that free rivers work better. And that's the general scientific consensus now, that the structures which impinge or impact on fish passage not only impact the fish, but they also impact the river. And that has long-lasting and serious problems with the river and how it functions. So in terms of the effect of structures on the river, in terms of, this is a nice simple diagram. The top structure there is a free-flowing river. The top image is a free-flowing river. As you can see, from top to bottom, there's no continuity issues, there's no problems. You can see you've got transport of sediments moving naturally downstream. Turbid flows, naturally different types of flows. You've got riffle pools and glides. You've got the water mixing thoroughly as it moves through. You've got natural connectivity of the water into the local aquifers. So there's like it's a proper dynamic system. You've got spawning habitat there, a natural temperature regime. So the regime is like as expected, or as expected by the fish that live in the river. So they're not being exposed to anything that they're not evolved to deal with. And you've got free passage of aquatic organisms. So, and it's not just fish that we're talking about here. We're talking about macroinverts, so you've got the invertebrates, but you also have plant material that moves downstream as well, and they move around the catchment like that. And then at the bottom image we have here, we have the dammed river in terms of what impacts the structure will have a dam or a weir or a culvert may have on a river system. As you can see, it's quite impactful. And this is not just talking about the passage of fish from downstream to upstream, or upstream to downstream. It significantly impacts the whole habitat of the river in terms of the sediment builds up behind the structure, the uniform flows. So all that natural flow types are gone. There's the river can be impacted for hundreds of meters in terms of impoundments. So the structure there impounds the water back, and you've turned what is a river into a lake. And that has a significant impact, because what happens is you lose all spawning habitat for sort of salmon and trout, and you sort of just completely disturb the natural processes that should be going on. As you can see there, you have an altered temperature regime, and in the times of climate change, this is not what we want. What you can have is a significant impact of the temperature. So in one study that we had, we saw that about the water coming out of a structure was 2.5 to 3 degrees warmer than the water coming into a structure after a sunny day. So that's a significant impact. And if you have multiple structures along a river corridor, you could be looking at very serious thermal impact in terms of whether the fish can actually survive there or not. So it can be a hazard. Some of these structures have been in the rivers for hundreds of years. They can be falling down. So not only a hazard for wildlife, but for people as well. But we also must be cognizant that they do produce a public benefit. So some of these structures are structures built for water supply. Some of them have historic significance. So in terms of managing a river, we have to balance all of these impacts against each other and try to come up with a common ground and consensus in terms of how we manage them going forward. In terms of fish passage and migration, the stuff on the fish species on the left at the top, the sea to freshwater migrations, these are the ones we typically think of in terms of fish migration and passage. You have your Atlantic salmon and your sea trout, and these are your iconic freshwater species that migrate to sea to grow and return to spawn and reproduce before migrating back to sea again. And obviously they are very significantly impacted because they have to pass over these structures to get to their natal spawning grounds. But there's other species here that we don't generally think of. We don't think of river or sea lamprey, or the European eels, or the Allis or Twite shad, which are very impacted because they're very poor jumpers and swimmers. So we need to be thinking of these. And I always say to my colleagues, I say we need to put our Water Framework Directive hat on and think past the salmonids and think about the whole the fisheries community which is present in the river. And we have to help all species to fulfill their life cycles and allowing them to migrate up and down rivers. Also, we have the freshwater fish would have just freshwater movement. They're called patadromous fish. So they actually spend their whole life in a river, but they also need to move. They also make migratory movements. So you have your pike and your bream and your roach and your brown trout. And you can see from this diagram on the right that they all have, like, if you think of your typical brown trout, let's say in the lakes of the West, they might be spending their summers in the lake. Then they'd make a spawning migration into their spawning grounds in the top of a small river. The juveniles would have nursery habitat, and then juveniles would return to the feeding habitat in the lake, and they'd also have overwintering habitat. So it's a very complex system, and man-made structures have the potential to break these complex systems and fragment habitat and prevent these migrations happening. And some of these species really don't have the capacity to pass artificial structures in rivers, and that's where we need to don our WFD hat and make sure that there's passage for everybody. So the implications of barriers for fish, and this is a very simple, it goes further than this because it affects the habitat too, not just the fish themselves. So these structures can delay. So if you think of an Atlantic salmon, he may have to wait for days or weeks or months even to get the right water conditions to get over a weir if the fish passage is poor. You can have a system where you have multiple barriers in a sequence. You have structure after structure after structure, and after each structure, the fish has to wait for the right water conditions to make passage over that structure. So they can be delayed. That'll delay them in terms of their reaching their spawning habitat. They can be physically damaged at the structure. If you ever watch a salmon, there's these wonderful videos of a salmon throwing himself at a weir or a natural waterfall. They can be badly damaged, and then they can get fungus, and they have very poor fitness. They are exposed to predators and poachers when they're stuck behind these structures or upstream of these structures. They can be exposed to high temperatures or low flows in terms of that, below a big weir or a big dam, the water temperature coming out of the dam might be significantly different from the water temperature going into the dam, and that might not be good for them. And then you've got to think about the loss of energy or condition that it takes to surmount these structures, even though they may be able to get over them, the amount of energy it takes to get over them, and that then is energy wasted that could be spent on sort of gametes, or sort of growing more eggs and milk for their reproductive success. And I'll just talk about two items here: the multiple barriers in a sequence, I have an Irish example, and exposure to predators and poachers, and how this can be effective, or how this affects these fish. Bottom right here, this is an example of an Atlantic salmon migrating back down to sea after spawning. So some of these Atlantic salmon, they can survive, they spawn and they survive, and they'll make their way back down to sea, but they have a tendency to get caught or trapped above artificial structures. And they can be held there for many weeks even. And as you can see on this fish here, it's got a fungus growing on it, and that fungus will only disappear once it gets back to the seawater. So it needs to make passage quickly. This is an example of a compound effect of structures. It's actually on the Blackwater Kilmacow down in Wexford. Bottom right here, you can see these are adult sea trout. They've been in the feeding in the sea all summer, and they want to go and spawn in their local river, the Kilmacow. So they're making their way, and they meet one barrier, then they meet another barrier, then they meet another barrier, and another barrier, and another barrier. So you've got multiple structures in a sequence that all can affect or slow down or stop waste energy of these fish as they migrate to the top headwaters of this catchment to spawn. And it doesn't just end there, because these fish and their offspring then have to grow, spend a year in freshwater, but then they'll migrate to sea, and they have to pass over each one of these structures on their way downstream. And as a lot of these things in nature, it's all quite complicated. These juvenile fish will be looking to get to the seawater at the optimal time, so that there's lots of food there waiting for them. So when they hit the seawater, there's food, and they can grow, and they can spend 2 years at sea probably, and then return to spawn. But if this migration, downstream migration, is slowed by all these structures, they might miss that window of food, and it would leave them at a loss. So it's one thing to be mindful of, that it's not just the adults that these structures affect, it's actually their juveniles as well. And then you can think about each one of these structures, how much habitat is lost impounded above these structures in terms of the riffle pool glide that juvenile salmon need for their recruitment. Then you have exposures to predators. This is an example here in America of pelicans feeding on adult, I think they're shad, moving upstream, and juvenile shad moving downstream. And in both cases, the pelicans are having a field day eating these fish that are being affected by this structure. In a similar case, this is an angler who's caught some fish below a weir. I mean, in terms of, he's removing fish from the system, in a place where we're artificially confining them, and reducing, the fish will pass that structure, but they're held there for a small period of time, and it makes them more vulnerable to predation. And it's one of those things that we all have to be mindful of, that you're exploiting at a point where they're vulnerable, and that has a knock-on effect for the whole catchment. Some of our drivers for change: European directives, got the European Habitats Directive and the Water Framework Directive. And in both cases, you can see the wording: obliged to maintain and restore the natural habitats. And these rivers that are affected by these structures, they have been significantly affected. And the water factor, the continuity of the river is not disturbed. That means that fish should be able to make passage unhindered upstream and downstream. Then we have the European Eels Regulation, and this is important. The EU Biodiversity Strategy for 2030. The Commission, aims to open at least 25,000 kilometers of river to a free-flowing state by 2030. So if we look at that and we break that down to an Irish context, we're talking about 1,000 kilometers of Irish river needs to be opened or freed up for unhindered fish migration. And that may seem like a lot of river, but if we're very smart and we're very strategic, we could probably do that by removing maybe about 6 structures or mitigating 6 structures. Types of structure. So you can see here we've got all forms of things in a river. If you spend time on a river, you'll know that man has been very ingenious in building all sorts of things to either slow water or stop water or pass water or cross water. But we have a lot of types of thing. And if we're considering how these structures affect fish, you must always be cognizant that fish can only do two things. They can only jump over it or swim over it. So you've got to think like a fish, and you got to look at these things and you say, how would a fish get over that? Would he jump over it or would he swim over it? And then, more importantly, does he have the capacity to jump or swim over it? And because we're wearing our WFD hats, we have to say, will the smallest fish in our river get over that? Not just the biggest, not just the Atlantic salmon, who is the extreme athlete, but will our minnow, will our roach, will they be able to make passage here? So we have two types of structures when we do our assessments. We have natural structures. These are natural waterfalls and rock sills. And we can no longer under WFD interfere with these. These are natural features. And they can be very, very, very significant and very important because they maintain genetic diversity within fish populations, because they're a natural barrier to passage. So one fish population upstream of a structure may be totally different to another fish population downstream. And then also, we have invasive species, and these structures stop invasive species. You don't have to do anything. They do it for you. So it's a really good thing to maintain these. And then we have artificial or man-made structures. We have dams, culverts, weirs, fords, and sluices. And we've broken them down to these simple terms because otherwise, in our culvert section here, that covers bridges as well, because you have many different types of bridges you have. So we had to be rigorous and very thorough in terms of renaming everything, coming up with a good naming culture. So for dams, the block or constrain flow of water, and mostly used for electricity or water supply. We don't have a huge number of these in this country. However, the ones we do have, especially 2, 3, have a very significant impact. This is Partine down on the Shannon. Like, that's a large amount of water upstream of that migratory anadromous fish have difficulty in reaching, and their juveniles have difficulty recruiting out of. We have culverts, which include bridges, and these structures allow a stream or river to flow through or under an obstruction. So bridges and culverts, you can see here. If you were a fish, how would you make passage over that? This one, you'd have to swim up through that high velocity water. This one, you'd need to jump up onto the bridge footing and then swim up through that very shallow water. We have more culverts here. And this is an example on the bottom right in the video of why these things, how these things stop fish. It's not just the jump into the structure that's the problem. It's the velocity of water coming through the structure. And in some cases, when you think fish should be making passage in terms of higher flows, they can't, because the water coming through the culvert is so fast, they just get blown out, like this little fella here on the bottom right. See, he just gets blown off the foot of the culvert because the water velocity is too high. We have our weirs, and we have quite a number of those. Not as many as the rest of Europe. We actually only have a few, well, a couple of thousand compared to Europe, where there's many hundreds of thousands. And these regulate flow conditions, and water was usually taken off for a mill. In the case on the right here, this is Athlone, and this is the for the navigation. Big structures, big problems at times. Fish passage, I'll go into it later in terms of how the fish passes were built, and in a lot of cases they're not WFD compliant. More example of weirs, generally under 5 meters in height. A lot of them are very old. A lot of them were built about the 1880s, 1850s, and are needing significant maintenance because the river is a very energetic place for anything to be, and it will break it after a certain period of time. We have fords. A lot of these cases, the fords are a problem. This one here is a problem due to the shallow water on the deck of the ford. A fish will try to make passage on that, jump up onto it, and he'll just flop around because there's no water for him to swim in. This situation here, got a couple of sort of pipes through the structure, high velocity water coming out of that. No fish is going to make passage to that. This one is obviously a jump up on top. So yeah, all structures that go into rivers, people need to be very thoughtful about how you put them in and how they affect the river. And then sluices, these are generally attached to our navigation channels. This is on the Upper Shannon. Yeah, so the sluices can be open and closed. The sluices themselves make very poor fish passage options because the velocity of the water is significant. And again, fish passage options that were built for salmonids. So as I was saying earlier, to understand the barrier effect, you must think like a fish and understand their limitations. And historically, people thought only about these guys on the left, the bottom left, these economically important species, the salmon, the trout. But we now, under the Water Framework Directive, have to be very mindful of these guys. And this is like, it's a river lamprey, shad, bream, and eel. And all of these are protected in one way or another, but they're very poor jumpers. They're very poor swimmers, and they really struggle against any form of drop or high velocity current or any turbulence in the water coming over these structures. So we have to redesign or rethink about how we provide passage for these fish under the Water Framework Directive and the Habitats Directive. So I've got a couple examples here of structures that we've surveyed around Ireland. This is just a bridge floor or the downstream of a bridge, bridge footing. And this was built to provide fish passage, this structure. And that's the fish pass just there. It's this long, shallow, fast flowing, high turbulence at the bottom, sluicey bit, as you could describe it. And in terms of providing fish passage, only Atlantic salmon adult Atlantic salmon probably have the capacity to swim up through that structure. And this is where we come to it. All these other fish species won't make passage on that because the water velocities are too high and the water depth is too shallow. So we have to be mindful of this. And this is like a common problem. And any problems here? This is a fish pass that was built in about the turn of the century. And it was designed specifically for adult salmon in terms of the jumping, their capacity to jump. They jump through this structure. And yeah, adult salmon will make passage through this, but these fish species won't. And this is a common what you see on fish passes in Ireland. And as you can see here, this quote from Silva. What we've done is we've looked at Atlantic salmon and we've applied their ability for passing objects to a whole load of structures around the world and build fish passes specifically for them without thinking of all the lampreys, the bream, the eel, or the pike, or the other fish that are in the catchment that now can't make passage because there's a structure there and the fish pass doesn't work for them. And then we have the culverts. And when you think about culvert, this is 95, maybe even more % of the problems for fish passage in Ireland are culverts, are these type of structures. They're on smaller rivers. And unfortunately, that's where a lot of the spawning fish want to go. That's probably where a better fish habitat is. And, it really fragments these high quality streams. And this is an example, bottom left here is up in Donegal. High quality, clean water upstream of that, and the fish will seriously struggle to make passage on that. And it's the same around the country. So in terms of like fish passage on big weir structures is iconic, and people see it and they say that is a real problem. But these structures, there's so many more of them, and they fragment so much better habitat that we should be really mindful of these as well in terms of where fish are spawning. And in terms of mitigation strategies, what we can do about this problem. We have some guidelines. IFI has guidelines and some planning for the urban environment, which is a very good steer if people see problems. It's a good way of dealing with them. In terms of barrier assessment in Ireland, IFI has we've been working for like the last 4 years on this. So what we've done is we've actually assessed about 30% of the structures in the Irish River catchments. And we've come up with an estimated number of about 10,000 barriers for fish passage in Ireland. So it's not something that's going to be fixed soon, but it's on the radar now. And hopefully that with the Green Deal and other European directives coming down the line, that things will be mitigated. And remember, dam removal science doesn't occur by itself. I mean, it's all nice to say we'd like to remove that structure, or that structure is very important and it's really impacting the fish populations in this catchment. But, you know, that doesn't work by itself. It has to be taken in context in terms of social, legal, historic, and economic context. And in some cases, something can be done or something can't be done. The weir may not, we may not be able to remove the weir. You might only be able to provide alternative fish passage options. Some example quickly now, you can see I'm running over time. Some quick mitigation examples. The weir removal, it's the #1 goal. It fits the Water Framework Directive, removes the problem. There's no fish passage issues. There's no upkeep after the fact. And the river is then back into a natural state. We have weir breaching, where a section of the weir can be removed and water can flow freely through that section, which is, so you may maintain some of the historical impact or historical nature of the structure. We have rock ramps, which can be constructed. So the structure is still kept in situ. It can be worked on culverts and weirs. So the weir is still in situ, but there's a significant long stepped sequence built to provide passage for all fish species. And then culvert mitigation. Generally the best option, if it's a very poorly designed culvert, is to replace it, but you can also step it out and improve fish passage. And this is what happens when management isn't undertaken and the the weir isn't looked after. It'll come apart. It'll fall down. This is down in the southeast, the south. 2005, 2018, capstones are falling out. 2019, the whole structure has collapsed. And that's just the nature of the river. It's a high energy environment and it'll break things. So every structure in the river has a lifespan, and we must be cognizant of how we're going to manage these things over time. Otherwise, you could have a significant failure or breaching, and this doesn't have huge repercussions, but other ones may have. And a quick an example of a weir removal in Denmark. As you can see, the weir was removed at this point. This is upstream of the weir. This is the trout density, numbers per meter squared. Downstream of the weir, this is when the weir was removed. As you can see, upstream of the weir was removed. The numbers of fish went all the way up. And even downstream of the weir, when the weir was removed, fish populations increased. And it shows you that when the weir was removed, the natural processes started to happen. And the fish population responded very positively to that. And one of the things I like to point out is people say, that we need the weir because it's got deeper water and it supplies, sort of place for larger fish to hang out or whatever. In this example here, upstream of the weir, when it was removed, the numbers of larger adult fish actually increased when the weir was removed. So it's something to be mindful of, that these animals have evolved to be in a natural river. And the more natural the river is, the more of them there will be. So on that note, running over, I say thank you very much. And any questions?
Fantastic. Thank you, Brian, for that really informative and thought-provoking presentation. I learned a new word there myself, patadermis. Hopefully I said that right.
Patadermis.
Fantastic. We have a few questions in. My colleagues Imelda and Rory have been busy in the background collating all the questions, and they're going to put them to you now.
Great stuff. Thanks, Brian. The first question here is, my local salmon river, the Eski in County Sligo, suffers from regular discharges of raw or partially treated sewage near the mouth of the river. Would this constitute a barrier to fish migration? Would this unnatural scent deter them from running and cause them to stray?
I'm not an expert in that. That's like behavioral fish behavior. I don't think so. I don't know. Honestly, I don't know. I'm going to put my hands up and say that's a very very localized effect. And unless if it was happening constantly the whole time, it could be like a thermal barrier to passage. But in terms of the release, what's coming out of this, I can't answer that. Sorry, apologies.
No worries.
Brian, the second question is about the Shannon. Given that the Shannon system drains a huge percentage of this country, when will IFI address the upstream and downstream migration issue at Ardnacusha, and Partine Weir in order to free up the unused habitat for juvenile recruitment?
Well, IFI is part of a group looking at the upstream and downstream passage at Ardnacrusha and Partine. And I think the ESB are hoping to instigate build a new fish pass in the next couple of years, I think, at Partine. But it's an ongoing project, and I think ESB are leading the way. So it's one of those things that will incrementally happen, I think, over the next couple of years, culminating in 2025, I think. But I'd say within the next 4 years, hopefully we'll see a new fish pass at Ardnacrusha or Partine.
Great stuff, Brian. The next question here is on the Bandon. Great presentation, thanks. But when will we learn, when one sees the enormity, scale and cost of the Bandon Pass, already damaged by floods and blocking passage of fish migration up and down the Bandon River? Just any thoughts on the Bandon in general?
I mean, speaking personally, I believe that our first option should always be remove the structure and allow natural process to happen. I'm not a big fan of constructing fish passage solutions. It tends to create alternative problems, and then you need to make sure that it works, that you need to have management in place for things like that that happen. So I would always be remove the structure first, and let the river do what the river needs to do, and it's generally the best course. But in some cases, historical, financial context, and choices need to be made. But removal would be my first thing, and then as natural like a fish pass as possible, or fish passage option.
Yeah.
This inquiry is wondering what weirs nationally have IFI targeted for removal, and in answering that, if you could say if Anacotta Weir is under consideration.
Anacotta is under consideration. It's one of on our hit list. So we have a list. So there's some on the Nore, there's some on the Barrow. We're working with other partners in terms of Waterways Ireland, and we're working with the OPW in terms of moving this problem along in terms of people who manage waterways. So things are afoot. Askeaton is hopefully going to be dealt with. What's the name of the weir you mentioned a second ago? Anacotta. Yes, it's on our list, and hopefully we will see some sort of thing happening with it. But it's very difficult. These are expensive things to do. I mean, in terms of just the paperwork alone for mitigating these structures, you're talking between 30 and 55,000 euros just to get your options report on what can be done. So there's not a never-ending sea of money out there.
Another question here for you, Brian. I think you kind of touched on this already, just in talking about fish passes. And anyway, dams don't have correct fish passes, only fish lifts, known as Mabolan lifts. There's no proof of smotes and salmon migrating down. Salmon then shouldn't be left above these dams until the study is done on each one to prove smotes and salmon can safely get back down. You mentioned fish got to the Galway Weir as salmon held up there for a time. It's in IFI's control. Maybe they should lead by example and stop the fishing there. I presume that means just below the weir, where salmon are caught.
Oh yeah. I mean, all of these things are in a social, financial context, and there's historic reasons why things happen and things don't happen, and there is a historic, fishery there, and yes, I would, it's a hard one. It's a hard one because I'm a firm believer of standing up for the fish, and let other interested parties make their arguments. So I would see that maybe there is some management that should be put in place to limit take, and there is. So some of these places like Galway, for example, the take is limited. It's not a free for all. The same with Ballina, maybe at the boxes, there's a limited take, and that's the way it should be, because you are artificially corralling fish, even though they're only slowed down there, they're not stopped. It is still a structure that we put there.
You mentioned, Brian, that removing a barrier can be costly. There's a question also here, should it be lowered gradually to avoid rush of water, or just demolished?
It all depends on the context of the structure and where it is and what's behind it. I mean, one of the when I started this, one of my colleagues turned around and said, there's two things that impact on weir removal and dam removal, is people and sediment. And if there's an awful lot of sediment upstream of that structure, you'll have to remove it. You'll have to lower it slowly. But if there isn't, you can be maybe removed in one go. You know, so sediment is a big issue.
Slight change of topic here, Brian. Has any work been done on the impact of hydroelectric extraction from a river, making the flow artificially low?
Not in the Irish context, as I understand. It was something we'd be liking to look at, and this is where we're touching up the Department of Housing for next, for the section 2 of the National Barrier Programme. We'd like to have other studies involved in that.
Brian, you showed a picture earlier of an angler with 2 fish that were caught below a weir. Could that not be banned, fishing below a weir?
Oh, in a lot of cases, it actually is. There's places where there's bylaws that say, you can only fish a certain distance downstream of a structure. That is the case. So yeah, and reduce the number of anglers. You know, it's all management, because in a lot of these cases that there is a historic element to where people fish and how they fish, and you can't just stop that. It's just about managing how people behave.
Thanks, Brian. One here, I think you mentioned at one stage that if we were trying to hit our targets for having our barrier-free river kilometres, you said the removal of maybe 6 obstacles would reach a target. Do you know what those 6 might be? Are you prepared to share?
It's all to do with funding and how much funding there is. I know there's a potential a complex of weirs down the southwest, and if they were removed, we get about 450 kilometres of free-flowing river. So, you know, it's about picking your structures. But also, it's not just about picking. We don't want to just say, yeah, we got 1,000 kilometres of river. We have to get 1,000 kilometres of the best river, the most important, where you get the best return for your money. Because we can free up a whole load of river, but if it's only, if it's heavily impacted with pollution, and if the river is very damaged physically, we're not going to see the return in terms of the high value species like salmon and trout or river lamprey or sea lamprey. So we have to be careful, and we have to prioritize accordingly.
Brian, this is the last question, and it's about Emmy Vale, County Monaghan. And the question is Emmy's Loch overflow old sluice on IFI's radar for removal or alteration?
It isn't. We know it's a problem. We know the river is being, almost the whole river in Emmy Vale is going down into the Emmy Loch, and the very little water going down the old course of the river. So yeah, it is in our radar. So that's all about I can say, I think, at this time.
Great, thank you.
Fantastic, Brian. Thank you very much for your time today and for your fantastic talk. And can I say thank you to all who participated as well through the questions and answer facility. Very much appreciated. Just a reminder as well, if you would like to head over to our Facebook page and our YouTube channel, please hit subscribe to keep up to date on any webinars that will be recorded during the week. They will be going up there later this week, but also we'll have lots of fantastic videos and posters and competitions going live on our Facebook page and on our YouTube channel. Before we finish, Brian, do you want to just pop back to your last slide just to show people the app where they can upload when they're out and about? If you download this app, is that right, that you can click, you can mark where you see a barrier?
Yeah, so this is the Citizen Science. We're a member of the Amber group. I think the Amber project has actually finished now, but that this actually resource is still available online in the Google Play Store. It's a really user-friendly app that allows you to, if you come across a barrier on the side of the river, you can, take a picture, you can assign it some values, and you can send it off. And that means that I can get a hold of the data after you've put it up there, and then it sort of merges into our national geodatabase for structures.
Fantastic. It's well worth downloading, and it's a fantastic resource.